Hi Year 11, this video is on the laws of logarithms. So we've got three main laws and these are all in your formula booklets. So the first one, if we've got log am plus log an, then that actually equals log a, m times n. So you have noticed there the value in the a spot needs to be the same. And then if we have two logs that are minus from each other, so for example log am minus log an, then that equals log a of m divided by n. And the last one, m log ab equals log a of b to the power of m. So if we have a power there, we can move it out the front, or if we have it out the front, we can move it to a power, and it becomes really useful, does that law. Now, natural logs is when we have log base e, and we'd never write log base e, we actually write ln instead, and that's only for if the base is e, and you'll see on your calculators you have an ln button next to the log button. And remember, log and exponential are inverse, so ln e to the power of x just equals x, because the ln and the e cancel each other out, and same with e to the power of ln x will just equal x. E and ln cancel each other out. And the last little rule is called the change of base rule. So if we have log ba, and we need to change the base, so we don't want the base to be anymore, we can change it by doing this formula. We do log, change it to our base that we want, which here is c, and then a divided by log cb. Okay, let's have a practice at some of these. So first of all, we're just going to simplify. So simplify log 5 plus log 3. So to do that, we're just going to use that first law. So log 5 plus log 3 will equal the log of 5 times 3, which will equal the log of 15. Now remember, if there is no base, we assume it is base 10. Okay, B, we've got log 2, 5 minus 1. Now we can't just do anything with this because the 1 isn't in log form. So what we need to do is put it in log form. So we'll have the log 2, 5. Now 1, if we go back to the rules from last lesson, we can rewrite 1 as log 2, 2. So anything to the base with a log with the base of 2, then 2 always equals 1. So log 3, 3 equals 1, log 4, 4 equals 1, etc. And then from here we can do our rules. So we've now got log 2. Now because they're minus, we're going to divide. So it'll be log 2 of 5 over 2. Part C, we've got 2 log 7 minus 3 log 2. So we're going to use that third rule for this first part. So 2 log 7, we can write that as log 7 squared. And 3 log 2, we can write that as log 2 cubed. And then we can simplify this. So log 7 squared will just be the log of 49 minus log of 2 cubed, which is 8. Then apply our law. So the log of 49 divided by 8. D, we've got 2 log 3 plus 3. So same as part B, we've got this plus 3 that we need to write as a log. So what we're going to do first, we're going to write log 3 squared. If we look at the first part, we've just got log, which means it's a base 10. So we need to write 3 with a log of base 10. So to do that, we write log. We know the base is 10, which means we need to write a 10 there, and to the power of 3. And the reason we do that is, I'll do an intermediate step here, is if we write 3 log 10, so log base 10, 10 is just 1, which is 3 times 1, and then that third rule, we can take the 3 to the power. Then we can just simplify this. So we'll have log 9 plus log 10 to the power of 3 is 1,000. So this will equal log of 9 times 1,000, which is a log of 9,000. E, we've got log 8 over log 4. Now to simplify this, we need to rewrite our log 8 and log 4, and this is how we're going to do that. So log 8 is going to become log 2 to the power of 3, and log 4, we're going to write that as log of 2 to the power of 2. Now if we do that, we can rewrite both parts of this fraction, and so we'll bring the 3 out the front, so 3 log 2 over 2 log 2, which means the log 2's will then cancel, and we end up with 3 over 2. And the final one, ln e to the power of 3. Now remember, ln and e are inverse of each other, which means they will just cancel out, and this will just equal 3. Example 2, we want to find x if ln x equals 2.17. So to do this, we've just got to think about inverses for rearranging. So if we have ln x equals 2.17, to get rid of an ln, we need to take the exponential. So x will equal e to the power of 2.17. So really we're taking the exponential of both sides because remember the exponential and log cancel each other out. E.27 in your calculator and you'll get that x is equal to 8.76 to 3 significant figures. Example 3, we want to change the base. So we've got log 29 and we want to change it to base 10 and change to base e. And this is basically to show that it doesn't matter what base we change it to, we'll still get the same answer. So for part A, change log 29. So log 29, change it to base 10, which means we'll have log base 10, which means we don't need to write it, 9 divided by log 2. So the base value goes to the bottom of the fraction. Put that in your calculator and you get 3.17. Now let's do the same by changing it to base e. So log 29 will equal, now base e remember is ln, so we'll have ln 9 over ln 2. Put that in your calculators and you will see you will get 3.17 again. So it doesn't matter what you change your base to, just as you just change to what's going to work for you. And example 4, if we have log 47 equals p and log 49 equals q, find log 79 in terms of p and q. So we've got log 79 and we want to rewrite this in terms of p and q. Now p and q both have a base of 4, so we need to rewrite log 79 with a base of 4. We can write that as log 49 divided by log 47. Log 49 in the question tells us it's q. Log 47 is p, so we'll end up with q divided by p. Now those types of questions do come up every so often in an IB exam. Now the next part we're going to do is solving equations, so solving log exponential equations. We're just going to go straight into this. So the first one, we've got 2 to the power of x equals 10. Now if we're going to solve this using logs, because that's what the question asks us to do, we're going to take the log of both sides. So we're going to take log 2x equals log of 10. Now the x is a power, which means we can bring it down the front, so it'll be x log 2 equals log 10, and then we can just go x equals log 10 divided by log 2, and then put that in your calculator, and you'll get that it is 3.32. B, 3 to the power of 2x equals 20. Once again, we want to take the log of both sides. Now remember, you can take ln or log, doesn't matter, so this one I'll use ln. Use either, you get the same answer. ln of 3 to the power of 2x equals ln of 20. Bring that 2x out the front. So we'll have 2x ln 3 equals ln 20. And then x will equal ln 20 over 2 ln 3. And then just put that in your calculator and x will equal 1.36. C, we've got 5 to the power of 1 minus 2x equals 50. Once again, same thing, take the log of both sides, use ln, use log, take your pick. I'm going to use log again, so we'll have log 5 to the power of 1 minus 2x equals log of 50. Now we're going to bring that power at the front. Now because it's an expression, it's 1 minus 2x, we need to put that in brackets when we bring it down the front. So remember your brackets there. And then we just rearrange. So divide the log 5 to the other side. And then just rearrange. We'll have minus 2x equals log 50 over log 5 minus 1. And then get rid of the negatives and divide by 2. So we'll get x equals negative a half times by log 50 over log 5 minus 1. And just put that straight into your calculator and we get that x equals negative 0.715. Next one, solve for x. We've got 2 times 3 to the power of x equals 5 times 2 to the power of x. So what we're going to do first here is the same thing. Take the log of both sides, ln, log, whichever you like. So we have log of 2 times 3 to the power of x equals the log of 5 times 2 to the power of x. Now because inside the brackets they're times in, we can undo that first law we looked at the start of this video. So we'll have log 2 plus log 3 to the power of x, so just undoing the steps we had previously, equals log 5 plus log 2 to the power of x. Now from here we'll put everything with x on the same side. So we'll have log 3 to the power of x minus log 2 to the power of x equals log 5 minus log 2. Bring the x's out the front. So x log 3 minus x log 2 will equal x log 5 minus log 2. Then we can factorise out the x, so we only have one x, so we'll have x bracket log 3 minus log 2 equals log 5 minus log 2, and then just divide to the other side. So x will equal log 5 minus log 2 divided by log 3 minus log 2. And then just put that in your calculator and you'll find that x equals 2.26. And then with b is slightly different. So if you look at b here, e to the power of 2x minus 3 to the x plus 2. Sometimes IB like to look at questions this way. These are kind of like those question 5, 6, 7s where you have to think a bit outside the box. Now what I'm going to do with the e first is I'm going to actually rewrite this first one, e to the 2x, as e to the x squared. So just reverse an index law, minus 3e to the x plus 2. Now in this situation, what you're going to actually find is it looks like a quadratic. I'm going to say let e to the x equal y. And then we'll end up with y squared minus 3y plus 2. And sorry, the question should actually be equals 0. Let's just add that in there. Now we have the quadratic. We just solve the quadratic. So you can do this by factorising, and we'll get y minus 1 and y minus 2 equals 0. So y minus 1 equals 0, or y minus 2 equals 0. So y equals 1 or y equals 2. And then we can just put our e to the x back in. So we'll have e to the x equals 1 or e to the x equals 2, and then solve this. So we'll get x equals ln1. Remember, undoing exponential, we do the log, we do ln. And the other side would be that x would equal ln of 2. Now ln of 1, just think back to when we have the log of 1, it always equals 0. So this means this will equal 0 or log of ln of 2. Then last example, just a worded one. So the radius r centimetres of a fungus on a tree can be modelled by this equation, where t is the time in days since the fungus was first observed. Say the radius of the fungus when it was first observed. Then after 4 days, the radius is 8 centimetres, find the value of k. And lastly, calculate how long it will take for the radius of the fungus to be 10 centimetres. So to find the radius when it's first observed means t is going to be 0. So r of 0 will equal 5 times by 2.4 to the power of k times 0. Now remember, anything to the power of 0 equals 1. So r of 0 will just equal 5, because 2.4 to the power of 0 is 1. After 4 days, the radius is 8 centimetres, find the value of k. So now we know the radius is 8, so it'll be 8 equals 5 times by 2.4 to the power of k, and it was 4 days, so it'll be k times 4. Now this is where we can start using logs to solve things. So your first step here I would do is do 8 divided, take the 5 over and divide by 8 by 5. So we'll have 8 over 5 equals 2.4 to the power of 4k. Now we can take the log or ln of both sides to rearrange, so we can have the ln of 8 over 5 equals the ln of 2.4 to the power of 4k. By doing this, it means we can bring that k out of the power so we can solve for it. So ln of 8 over 5 will equal 4k times by ln of 2.4, and then we can just divide everything but the k to the other side. So we'll have ln of 8 over 5 divided by 4 ln 2.4. Once again, just put that in your calculator and we'll end up with k equals 0.134, and that's rounded to 3 significant figures. Part C, we want to calculate how long it will take for the radius of the fungus to be 10 centimetres. So this is very similar to part B. So we want the radius to be 10, so we'll have 10 equals 5 times 2.4. Now we know what k is. We know that k is 0.134. So 0.134 times by t. And we just use the same process as we did with rearranging to find what t is. You put in your calculator and t will be approximately 5.90 days. And that's how we rearrange with logs and solve equations. Now the only thing we've got left to do in this topic is the derivatives of logs and exponentials, and that will be the next video.